This only says right here that you can take, if you take the log of one side, you have to take the log of the other side.
How do you know?
So it's kind of like me going to this equation right here, and then taking the log of this side and the log of this side. Whatever you do to one side, do the other side. It's like the same thing you guys learned when you were doing Algebra 1. Whatever you do to one side, do the other side. Now, when would you ever want to take a logarithm of something? I will show you. You see this equation that we're trying to solve? It has an x in the variable. Now, how the heck do you get an x out of variables? I'm sorry. I'm saying variables. It has an x in the exponent. How do you get an x out of an exponent? This is when you use logs. See, check this out. Let me rewrite this so we can have more space.
Look at it.
I know it's trippy. Okay, if I take the log of each side, this is what it's going to look like. So I took the log of each side. Now, why would you do that? Well, check this out. What can I do with this exponent now that it's inside of a log? Drop him like he's hot. So now I have 10x times log of 10 equals log of 100. Now, I'm writing extra because I want to make sure you guys are following me. Now, what is log of 10? Come on, people. Uno. What power of 10 equals 10? 1. So this is really just a 1 right here. 10x times 1 is just 10x. Let me rewrite that. We have 10x equals. Now, what do we get on this side? Do you guys know what log of 100 is?
2.
Yes, it's 2. Another way to write 100 is 10 squared. And so you would know that, oh, look at this. That's a 2. So now I get x equals 2 divided by 10, which is the same as 1 over 5.
Why'd you get rid of the log?
log 10?
I'm going to interrupt you guys now. I hope that you guys tried this first. You wrote log of 10 to the x minus 1 equals log of 1 over 10 to the x minus or plus 1. Did you guys all write that?
No.
Okay. Now the first one on the left side is not that bad. You take that exponent and you drop them. Right? So I have...
Can you move it up?
Can you move it up?
Move it up.
Oh, okay.
Alright, so this is what we got now. We have x minus 1 out in front, and it's multiplying to the log of 10. Now that's nice, because I like log of 10. What's log of 10?
Uno.
This equals a 1. So this times 1 doesn't really matter. So let's go over to the other side, though. Because this is kind of weird. We have a fraction in here. Now, do you remember some kind of cool trick right here? There's a property that allows us to make that not a fraction anymore. Yes, we put a negative in front of the log. This is one way to do it, guys. There's other ways to think about it, but this is what we've worked on so far. Now, I don't have a fraction anymore, and it's beautiful. Look how beautiful it is. You're going to do the same thing that we did with the other one. We're going to take this, and we're going to drop them out in front, but there's a negative there, so that means we're going to have to multiply it by -1.
Huh?
Okay, or, I mean, you can write it like this. Here, let's write x minus 1 in the front, on the left side, and then on the right side, we have an x plus 1 times -10, or negative log 10. And what is log 10? This is a 1. And so now that's really a -1, right?
Yeah.
So we got -1 because of this negative right here.
Wait.
So let's distribute that -1. So now we have x minus 1 equals -x minus 1. That's weird. Alright, so we get x alone on one side. So let's first add x to both sides. Peace out. We have 2 x's right here. Oh, and we have a -1 equals -1. Then we have to add 1 to both sides, and so we get 2x equals 0. So x equals?
0. So what do you do with the 2? Just...
I'm going to go ahead and write this because sometimes you guys get tripped up over it. If I divide by 2, what's 0 divided by 2? That's how I get 0. So I get x equals 0. Alright, so I gave you a chance to do it on your own. This is how it goes.
Wait.
No, I can't wait anymore. Log of 100 raised to 2x equals log of 10 raised to 3x minus 1. So I just logged both sides. Why did you log both sides? Because there's a variable in the exponent.
Yeah, I did something.
So I'm going to take this exponent and drop him like he's hot, and take this exponent and drop him like he's hot. So we got 2x times log of 100.
It's 2.
Yeah, that's just a 2, right, people? And then this one's going to say 3x minus 1. What's log of 10? A 1? Oh, that's lame-o. I wanted to have to distribute something, but if you distribute a 1, that doesn't really do anything. What is 2x times 2? 4x. And then we have 3x minus 1. How do we get x alone on one side? We'll subtract the 3x. Okay, don't mean to be all sassy and stuff. We have 1x equals negative 1. Oh, look. X is all alone. Yay, we're done. Okay, let's solve these guys. Now, again, we have variables in the exponents. We're trying to get that variable alone. Actually, I'll make a different video for this one.